guys, welcome to my channel where we will simplify our understanding of knowledge. Today we are going to study one of the most important topic of class 9, Newton laws of motion. If you see, motion is all around us. Whether we walk on the road, whether we play a game of carom, whether we play a game of pool, or whether we are simply taking a lap in the swimming pool. All these are governed by Newton's laws of motion. In this class, we will cover two topics. We will get a brief perspective, historical perspective on the laws of motion, and we will study Newton's laws of motion in detail. Greek philosopher Aristotle observed that all objects moving by itself eventually comes to rest. He argued that objects, much like humans, eventually come to rest when they lose all their energy. Then came Galileo, who observed the moving pendulum and made an interesting observation that the bob of the pendulum reached to the same height on either sides. He also made an interesting observation that speed of the pendulum increased as it came down and decreased as it moved up. He then argued, what if he drops a ball on a U-shaped container? Will it behave like a pendulum? And yes, it did. The ball reached to the same height on either sides. He also observed that ball reaches the same height irrespective of the shape of the container as shown in the picture. He then argued that the speed of the ball will remain constant on the flat surface of the container as the ball is neither coming down or moving up. Now here comes the eureka moment, a thought of what will happen if the right side path is very long with a very small slope. He argued that ball will keep moving to infinity with a constant speed. After 50 years of Galileo's work, Newton came with the three laws of motion, which is based on the pioneering work of Galileo. Newton's first law is based on Galileo's observation and states that an object at rest continues to be at rest and an object in motion continues to be in uniform motion unless acted by an external unbalanced force. Newton's first law gives the observer a clue about the presence of an external unbalanced force which causes the change in uniform motion, or in other words, causes the change in uniform velocity. Change in velocity can be because of three reasons. Either the velocity increases, velocity decreases, or the direction of the object changes. So, if we see the body accelerating, decelerating, or changing direction, we can conclude that there is a net external unbalanced force acting on the body. In other words, if there is no net external unbalanced force acting on the body, then the body should be at rest or should move with uniform motion. Now we come to the Newton's second law of motion. Newton's first law of motion gives us a way to detect the presence of a net external unbalanced force. Newton's second law of motion gives us a tool to calculate the net force. By everyday experience, we know that different amount of force when applied on the object of same mass will produce different acceleration. For example, a footballer has to kick the ball harder to make it move faster. From this, we can say that force is proportional to acceleration. We also know that to provide the same motion or acceleration, more force is required for the heavier object. For example, you need to apply more force to a lighter tennis ball as compared to a heavier basketball to produce the same motion. This means that force is proportional to the mass. Given above two observations, Newton gave the second law that measured the force in terms of mass and acceleration. As per Newton's second law, the amount of force is equal to the product of the mass of the object and the acceleration of the object. Since force is the product of mass and acceleration, the unit of force is the product of unit of mass and the product of unit of acceleration. So we see that the unit of force is kilogram, which is the unit of mass, and meters per second square, which is the unit of acceleration. So the unit of force becomes kilogram meter per second square. Newton then gave a special unit of force called Newton, and he said 1 Newton is the magnitude of force when applied on an object of mass 1 kilogram produces an acceleration of 1 meter per second square. Newton's first law and second law analyzed the effect of force on a single body system or a single object system. However, in nature, we rarely see the existence of a single body system. For example, you see the book lying on the table. Here, the book is interacting with the table, and both the book and table are in rest. Similarly, when you play a game of carom, you see the striker interacting with the coins in the carom board. Also, in a game of cricket, the bat interacts with the ball for different kinds of shots. Newton's third law quantifies the magnitude and direction of the force between the interacting objects. It states that in any interaction between two objects, the force applied by the first object on the another is equal and opposite to the force exerted by the second object on the first. This means that for interacting objects, forces always exist in pair. Let's try to understand from a simple example where a book is kept on the table. The book is at rest. From Newton's first law, we know that there is no net external force on the book. We know since the book is at rest, the acceleration is zero. From Newton's second law, we know that force is mass times acceleration, and since acceleration is zero, the net force is zero, which kind of supports our observation of Newton's first law. Now let's try to understand the forces involved between the book and the table. By experience, we know that the book exerts a force on the table because of its weight. Since the book is not moving, this means that the net external force on the book is zero. Now we see only one force, which is the weight of the book. So to balance this, we can argue that the table is exerting the same force equal to the weight but in the opposite direction. This force exerted by the table on the book is called the reactionary force, and it balances the force due to weight. It is the reactionary force is equal and opposite to the direction of the force due to weight of the book. This satisfies the Newton's third law of motion, which states that the forces always exist in pairs, action and reaction force. So guys, with this we come to the end of this class. Hope this has slightly improved your understanding of the concept of motion and laws of motion.